In this video, I'd like to talk about the math question of the day for Saturday, June 10th, 2023. And with this example problem, we need to find the derivative of this function, this rational function here. And derivatives are taught in a Calculus 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And since we have a rational function, we have a quotient here, and we need to find the derivative of this quotient function, we will need to use the quotient rule for derivatives. So let me write that down. I will show it to you, but I will not prove it in this video. Let's say we have two functions, f of x, and the second function is g of x, and that we are finding the quotient of these two functions. And we want to find the derivative of this quotient with respect to x. We'll assume that each of their independent variables is x. Now, in the numerator, we find the derivative of the numerator function, f prime of x, and then we multiply it by the denominator function. Let me just make a slight amount more room. And then we subtract the derivative of that denominator function multiplied by that numerator function, f of x. And apologies, I'm running out of space there. And then we can divide by this denominator function squared. So this is the quotient rule for derivatives. And of course, you could write it a little bit cleaner if you want without all the function notation. You have f prime multiplied by g minus g prime multiplied by f all over g squared. And you can see it's similar to the product rule, except we are subtracting in the numerator, and we're subtracting the term with the derivative of the denominator, and then we divide everything by this denominator function squared. And of course, in the product rule, we just have the plus sign, and we're not dividing by anything. Now, if we assume that this function, r of w, is really just two functions that we're finding the quotient of, we could say we have f of w in our numerator and g of w in our denominator, then we can apply this formula here. So let's find this r prime of w, the first derivative of this function r with respect to w. And we will need the derivative of this numerator with respect to w, and then we'll multiply it by this function in our denominator. This g of w is what we can call that. And we'll just use the power rule. We look at our exponents, we bring them down in front, we multiply, and then we subtract the exponent by 1. So for this numerator function, we're here in our formula, we are finding the derivative of this. We bring the 1 down, 1 times 3 is just 3. Then we decrease the exponent, so it becomes w to the 0, which is just 1. So we can just leave that as 3. Then for the second term, we bring down the 4, and we subtract the exponent by 1. So the derivative of w to the 4th is 4w cubed. And now we are at multiplication by g, this bottom function, which is just 2w squared plus 1. And then we subtract the derivative of the bottom function. We just apply that power rule. We bring the 2 down in front. We get 2 times 2, which is 4. And we subtract that exponent by 1. And then for the second term, it's a constant, and we know the derivative of a constant is 0. The rate of change of a constant is 0. They do not change. Then we multiply by that numerator function. We just did that step, and now we're multiplying by our function f of w, which we know is 3w plus w to the 4th. And all of this is divided by that denominator function, g of w, and we will square it. So we have 2w squared plus 1, and then all of that will be squared. Now, at this point, technically, this is our final answer, and it varies teacher to teacher whether or not you should simplify this. It is beneficial to simplify it in many scenarios because you might need to find another derivative, and you might not want to use the product rule multiple times. So let's simplify all of this, though like I mentioned, technically this is our final answer. This is the derivative of our function r with respect to w. But let's clean everything up. We can just multiply all of this out. We will distribute the 3, then the 4w cubed to this second factor here, this expression. And we would get 6w squared. 3 times 1 is 3. Then 4w cubed multiplied by 2w squared would be 8w to the 5th. 4w cubed multiplied by 1 is just 4w cubed. Then for this one, we just distribute the minus 4w. So we get minus 12w squared, and minus 4w multiplied by w to the 4th be minus 4w to the 5th. And then all of this is divided by this denominator, and since we're squaring it, we could rewrite it twice and then distribute. We have 2w squared multiplied by 2w squared, which is 4w to the 4th. Then we multiply these two together, and really we double that since we're doing it twice. So we get 2w squared multiplied by 1, which is 2w squared, and we double that, so we get 4w squared, and then 1 times 1 is 1. And if that was confusing for the bottom, just rewrite this expression twice and use distribution like we used here. And let's combine like terms just so that everything is a little bit neater. We have our 5th power terms, 8w to the 5th minus 4w to the 5th. That is just 4w to the 5th. Then we have no 4th power terms. We have 1 cubic term, so plus 4w cubed. And we have quadratic terms here, 6w squared minus 12w squared. That's just minus 6w squared. And we have one constant term, so we'll add 3 at the end. And our denominator remains the same since it's already written in simplified form. So 4w to the 4th plus 4w squared plus 1. So this right here, as you can see, is a much simpler looking answer. And the advantage to this is that if we want to take the second derivative of this function r, we can now just apply that quotient rule again, and it's relatively straightforward. We'll just use that power rule when finding the derivatives of our numerator or the denominator.